Hello, this is the fourth episode for my Industry Briefs blog for my assignment. This week was a significant milestone in the development of my enemy AI, as I made a decision that will benefit the project's timeline, as well as following up on a player experience development that I wanted to include a couple of weeks ago, as well as what I'm focusing on next week. As mentioned last week, I wanted to investigate what factors the ALS actor uses to calculate speed and how I could modify the stat to align with my outlined plan. So I did some digging into the parent of my enemies and I discovered a variable using a structure that provided access to different movement speeds depending on the player's state. Next, I had to track down where these variables were being pulled from, which led me to a movement data table containing all the movement information. This included different states, varying speeds depending on aiming, walking, running, as well as vector curves. I began altering the values and using a print string to check when I had modified the correct movement value for testing, which worked. However, I then encountered my first major problem. My intention with the change in speed was to affect just the enemies, but changing speed inside the data table also affected the player, which meant I'd need to have one for the player and one for the enemies, which then meant that I couldn't have them parented to the same actor, since if I changed the table to a dedicated one, it would still result in them both being affected by the change. So my last resort was to duplicate my own copies of the table and the parent and create a version of each dedicated to the player and the enemy base. This was satisfactory. I could now modify the speed of my enemies and not affect the player, but then another issue cropped up that was bugging me with the enemies. When the enemies first initiated the behavior to move to the player, they would begin running at the intended speed, but as they closed in on the player, they gradually slowed down. As well as when they were shot at, they gently wander over to cover, still making them a very easy target, and with enough time to completely kill them before reaching the cover. So it was back to the movement data table to continue working out how to fix this problem. What I believe to be an effect on this issue was the inclusion of the vector curves, something I'm not familiar with, and what they were actually doing for the actor it was assigned to. My presumption, since it isn't mentioned in the table, was that it was affecting how the speed should change across a period of time. Whether that is true or not, I am unsure, but it is the most logical explanation to me. I did mess around with the vector curves, but couldn't find a suitable solution to my problem, and having already spent a collective of 2 hours on figuring out where the speed comes from, how to change it, and reparenting my actors, I was becoming increasingly irritated by the setbacks. So I made the call to completely change my AI actor to something I could comfortably work with at the cost of accuracy. For the past 3 years, I've worked with the default Unreal Engine mannequin, its components, and its whole setup. So I created a new third person template and migrated the base actor into the project and reformatted its behaviors and blueprints to use this new enemy base instead. Obviously, the switch to a different mesh and character does mean I no longer have set out stances and equipment for them to use, and most notably, they could no longer crouch when I wanted them to. However, being familiar with the regular setup of a mannequin, I knew I needed to toggle the ability to crouch in the movement component, but now my issue is that the default pawn doesn't have a dedicated crouch animation. I've used the Mixamo website for several projects, so it was pretty easy to reach this as a fitting solution to this problem. I downloaded a crouch down animation and an idle crouch animation, along with a random skeleton. Importing just the skeleton into my project, I then had a compatible asset for the animations I was going to use. Following this, I retargeted the animations to the Unreal mannequin and duplicated the crouch down animation to reverse so that I also had a standing up animation. Finally, I went into the animation blueprint to implement the crouch animations and when they're triggered, which I was familiar with from Tactics T and Tentacles. As mentioned, I think this was a bold decision to make after spending so much time figuring out and getting used to the ALS character. However, in previous blogs, I documented that the characters had some issues that I found to be very inconvenient, with the health bar widget not being able to be created on Event Begin Play node specifically. So switching it out for the default has definitely come with some benefits. Likewise, one of the elements I wanted to achieve is this realistic depiction of how the Division 2 feels, and the player does still move and function like the agents in the game, so sacrificing the enemies to function better for a more comfortable experience is still better in my opinion. My final addition for this week was finally including something to help the player understand where they're actually aiming and shooting at, without the reliance of the player shooting from a line trace. I had already tried to create a crosshair in the center of the screen, but the line trace would always deviate or be off the point, especially when the player was moving around. This was down to the fact that I had the trace coming from the muzzle of the player's gun, which meant when the arms of the player swung and moved the gun, accuracy was effective. So to have an accurate crosshair that actually hit its target, I looked into a different solution. I discovered the get viewport size node, which when I split the result pins, it gave me an X and Y value. To get to the center of the screen, I divided the two values by 2 and plugged that into the project screen to world, which takes a 2D value and converts it into a 3D space, giving me a position and direction value. Following the same maths of the position being the starting point and then multiplying the direction by the range I wanted it to reach, in this instance 5,000, before adding it also to the position value to be my endpoint. This now allows the player to be very accurate with where they aim, but I no longer need the line trace to make it easy to see where I'm shooting. Obviously, the permanent increase in accuracy to always hit the mark is a little overpowered, especially when running and shooting would reduce accuracy greatly, but for the time being, I'm satisfied with this development. My next developments will be adding additional behaviors to the AI so that they can have some additional tactics and behaviors to make them a bit more interesting in the combat situation, which, if I manage to develop swiftly this week, I will then begin developing the more unique behaviors for different enemy archetypes.